హాలిడేస్ ఉపయోగించుకో పోతే वही లాస్ ఆఫ్ पे అవుతుంది ఏం చేస్తాం हेलो हेलो आवाज़ क्लियर है एक बार वॉइस कंफर्मेशन कर दीजिए बेटा यस नमस्कार दोस्तों वेलकम टू गेट वाला मैं हूं सतीश कुमार द्विशेट्टी फैकल्टी ऑफ COA कैसे सब लोग आज हमने COA डिस्कस करेंगे आज COA में इंस्ट्रक्शन पाइपलाइनिंग का टॉपिक डिस्कस करेंगे जल्दी से जल्दी ज्वाइन करो बेटा तो लास्ट क्लास में हमने एड्रेसिंग मोड्स डिस्कस करते रहे तो एड्रेसिंग मोड्स थोड़ा सा पेंडिंग है सम ऑफ द एड्रेसिंग मोड्स वी हैव टू डिस्कस उसके बाद हम जरूर हमने इंस्ट्रक्शन पाइपलाइन भी डिस्कस करेंगे ऑल ऑफ यू प्लीज लॉग इन एंड प्लीज गिव मी योर रिस्पॉन्स जल्दी से जल्दी गुड मॉर्निंग टू वन एंड ऑल एक बार वॉइस कंफर्मेशन कर दीजिए बेटा सब कुछ ऑडियो वीडियो सब कुछ क्लियर है Please give the voice confirmation. All clear है? So आज का टॉपिक है इंस्ट्रक्शन पाइपलाइनिंग। इसके पहले हमने एक बार रिवाइज करना चाहता हूं जो कुछ टॉपिक्स हमने लास्ट में डिस्कस किया है एक बार रिवीजन करना चाहता हूं। हमारा लास्ट क्लास पे हमने एड्रेसिंग मोड्स डिस्कस करते रहे एड्रेसिंग मोड्स में सम ऑफ द एड्रेसिंग मोड्स पेंडिंग है वो कंप्लीट करने के बाद आज का क्लास को जाएंगे। सो व्हाट आर द एड्रेसिंग मोड्स वी हैव डिस्कस्ड द इमीडिएट इंप्लाइड मोड एंड वी हैव डिस्कस्ड द इमीडिएट एड्रेसिंग मोड। तो रिवीजन क्या है एड्रेसिंग मोड्स पर डिस्कस किया है। सो एड्रेसिंग मोड्स में हमने ये कंप्लीट हो चुका है इंप्लाइड हो गया इमीडिएट हो गया डायरेक्ट हो गया इनडायरेक्ट हो गया रजिस्टर भी हो गया ओके। सो एक बार हम ये नॉट कंप्लीटेड इसके बारे में भी डिस्कस करके हम जल्दी से जल्दी उसको ज्वाइन करेंगे। एक बार वॉइस कंफर्मेशन कर दीजिए बेटा जितने लोग लाइव में हैं मुझे एक बार कंफर्मेशन कर दीजिए। एवरीबॉडी प्लीज कंफर्म योर status over there. Very good. Is audio video is clear? सब कुछ ठीक है? Okay. चलो my dear. So first of all let us revise what are these addressing modes. फर्स्ट इम्प्लाइड एड्रेसिंग मोड में आपको डेफिनेशन इटसेल्फ डिपेंड्स द ऑपरेंड। तो उसका एग्जांपल क्या है उसका एग्जांपल आपकोड इटसेल्फ दैट मींस इफ यू टेक हॉल्ट और इफ यू टेक ऐड दैट्स इट ओके। कॉम्प्लीमेंट अक्यूमुलेटर क्लियर कैरी सेट कैरी ओके। सो दीज आर सम इंस्ट्रक्शंस इज इट क्लियर। So these are certain instructions. Hi Kajal, how are you? Have you followed my previous classes? मैं एक रिक्वेस्ट करता हूं आप सब लोग को लास्ट ईयर ऑल्सो हमने YouTube पर क्लासेस लिया है एंड वो भी रिफर कर सकते हैं आप। थोड़ा सा टाइम की कंस्टेंट्स है थोड़ा कंटेंट उसी समय हमने ज़्यादा नहीं पाए अभी इधर अच्छा कंटेंट आ रहा है आपको सो वो भी फॉलो कर सकते हैं। सो आप डायरेक्टली हमारा PW का जो कुछ गेट वाला का वेबसाइट है गेट वाला का YouTube चैनल है वो YouTube चैनल में आप रिफर कर सकते हैं COA का लेक्चर्स ओके। वो पूरा लेक्चर्स आप पढ़ लो एंड दैट इज मोर देन इनफ फॉर योर एग्जाम ओके। एज पर द ECE गेट कंसर्न as per the gate ECE concern that is more than enough okay। Chalo, add CMA, CLC, STC. So these are some couple of implied addressing mode. So no operand. So no operand. No operand. Instruction itself. Opcode itself explains the operation. Opcode itself explains the operation. Opcode itself explains the operation. Okay. चलो, let us go for the next. इसके बाद immediate addressing mode है. Immediate addressing mode के example है. Immediately number will be there. Can you give an example, काजल? What is the immediate addressing mode? अगर आपने microprocessor subject पढ़ चुका है, इसमें microprocessor subjects आप दे सकते हैं. Can you give an example? इमीडिएट एड्रेसिंग मोड के लिए एग्जांपल दे सकते हैं आप? So immediate addressing mode में data will be there. So the address field of the instruction specifies the operand value. Operand value. Okay. For example, here move AL comma 22. Okay. Or move AX comma 1213. MVI A comma 24, or move A comma, or move any register R0 comma hash 22. So these all are the immediate addressing mode. So one of the operand is directly the number. So this is for 8085 microprocessor. This is for 8086 microprocessor. This is for 8085 microprocessor, and this is for 8051 microcontroller. Okay, so these are the some set of the instructions. Move AL comma 22, move AX comma 1213, move A comma 23, move R0 comma hash 22. Okay, so these are some set of instructions. Okay, so this is the immediate addressing mode. So let us go for the next. Next one is a direct addressing mode. In direct addressing mode, we are going to specify the address. In the address, the operand will be there. See here, there is a memory. In the address, this is the address. In the address, there is an operand. See, for example, if I am writing an instruction, load accumulator 2000. 2000 is the address. So this 2000 is the address. In the 2000 we are having a number, so that number will go to the accumulator. Is it clear? So directly where the operand is present, that address we are giving. Is it clear, my dear? Where the operand is present, that address we are giving directly. For example, if I want to write store accumulator, suppose if I am taking this accumulator, for example, let us take accumulator value is suppose 15, store accumulator 5000. So where this contents of the accumulator has to go to the 5000 memory location, so I am giving this 5000 memory location. So this accumulator content go to this, so here comes the 15. Okay, so this is the opcode, this is the address, this is not the operand, this is the opcode, this is the address at which operand is present, at which operand is present. Understood, my dear? Very good. Move immediate r comma no pass of buffer. क्या हो गया भैया काजल? Move immediate r comma data, that is going to be immediate addressing mode. एक बार आपने move immediate दिया, एक बार आपने move immediate दिया, that is going to be the immediate addressing mode. That cannot be other addressing modes. एक बार instruction में a है, I बोले तो move immediate a comma 23 means एक बार इंस्ट्रक्शन में आई है, आई का मतलब है इमीडिएट, दैट मीन्स इमीडिएटली आपने नंबर अक्यूमुलेटर को भेज रहे, इमीडिएटली आपने एक कंटेंट को रजिस्टर को भेज रहे. समझ गए आपको? अगर आपका आपकोड में आई लेटर है, मूव इमीडिएट, ऐड इमीडिएट, सब्ट्रैक्ट इमीडिएट, वो इमीडिएट का मतलब है वो कामा के बाद डेफिनेटली आपको एक नंबर रहेगा. समझ गया काजल जी? इंस्ट्रक्शन में आपको आपकोड में आई लेटर है, then definitely it is going to be the immediate addressing mode. Try to understand. इंस्ट्रक्शन में आपकोड में आई लेटर है, then it is going to be immediate addressing mode. Is it clear? क्लियर हो गया? So that is going to be the immediate addressing mode. Any other doubts? ओके चलो, ये पूरा हम डिस्कस किया लास्ट क्लास में. नेक्स्ट उसके बाद डायरेक्ट भी हो चुका है. उसके बाद डायरेक्ट का और एक नाम है, ये भी नोट कर दो, सम ऑफ द टेक्स्ट बुक्स में डिफरेंट होगा. सो डायरेक्ट का और एक नाम है, दैट इज कॉल्ड अब्सोल्यूट एड्रेसिंग मोड. डायरेक्ट के लिए और एक नाम है, क्या है वो? अब्सोल्यूट एड्रेसिंग मोड. चलो नेक्स्ट, इनडायरेक्ट एड्रेसिंग मोड. इनडायरेक्ट एड्रेसिंग मोड में हमने एड्रेस को इंस्ट्रक्शन में डायरेक्टली मेंशन नहीं करते हैं. We'll mention in the instruction in location where the address is present. In that address the operand is present. So here the address field of the instruction specifies the address of the effective address. The address field of the instruction specify a register which holds the operand. See here. See, for example, it is effective address. So number of memory access to get the operand is 2. Mode is used to implement pointers. So how many number of times you are referring to the memory? 2 times you are going to refer to the memory. Yeah, that is another addressing mode. In and output port, very good. That is in and output port hash. The hash is related to microcontroller. In and output they are related to port addressing mode. Yeah, port addressing mode. That is actually a separate addressing mode. हमने उसमें address दे रहे हैं. Actually we can say, we can take it as a direct addressing mode itself. Very good. आपने जो बोल रहा है in and address. Suppose if I am taking in AL comma 80H, yes or not, out 90H, out AL to the 90H. So these are the address. Remember my dear students, this is not the number, this is the address. So हम उसको वो direct addressing mode भी बोल सकते हैं. Actually इसको port addressing mode बोलना है. So these are related to port address, right? This is a port address. This is a port address. ये भी port address है. ये भी पोर्ट एड्रेस है। मजा आ गया? Is it clear or not? कंफर्म कर दीजिए बेटा काजल। दैट इज एड्रेस, दैट इज नॉट द डाटा। साउंड आता है। गुड मॉर्निंग, डू अंडरस्टैंड राकेश? काजल जी क्लियर हो गया? Good morning. चलो, this is actually we can call it as a port addressing mode. This is a port address, but anyway we can take it as a direct address mode because हमने address mention कर रहे हैं इसमें। चलो, उसके बाद indirect addressing mode. Indirect addressing mode का example मैं देता हूँ। See, for example, if I am writing like this, move AL within the square brackets 100 and again 100. What is it? What is the meaning of it? 100 is the effective address. It will go to that effective address. In that effective address, we are having certain value, some 50. This 50 represents again an address. It will go to 50 address. It will go to the 50 address. So this is the 50. So in that 50, the operand is present. You understand? That means whatever that is mentioned, okay, whatever that is mentioned in this particular effective address, that is not the data. You have to go to there, and from there you will get an effective address. An effective address in the effective address, that is what we call as indirect addressing mode. समझ में आपको? So यहाँ गया आपने 100 को 100 एड्रेस को गया, 100 एड्रेस में क्या है 50 है, तो दिस 50 इज अनदर इफेक्टिव एड्रेस, दिस 50 इज अनदर इफेक्टिव एड्रेस, उसमें गए तो आपको ऑपरेंड मिलेगा। समझ गया आपको? सर हम 2025 में गेट का एग्जाम दे रहे क्लास में तो समझ आ जाता है, बट पीवीक्यू नहीं बन पाता है, उसको प्रैक्टिस करना पड़ेगा राकेश जी। कॉन्सेप्चुअली आप नोट्स मेंटेन करना है, सिलेबस को अटैच करना है, टॉपिक वाइज जाओ, टॉपिक वाइज गो एज पर द टॉपिक। एक बार एक टॉपिक पढ़ो, टॉपिक के बाद उसका गेट का पीवीक्यू करो, वो अच्छा होगा। ओके, प्लीज डू द टॉपिक वाइज पीवीक्यूज, दैट विल बी बेनिफिटेड फॉर यू। ओके ना? गेट 2025 के लिए बोले तो बहुत अच्छा टाइम है, आप आराम से एक एक टॉपिक को चूज करके एक एक टॉपिक को क्वेश्चंस करके जाओ। ओके ना? डू यू अंडरस्टैंड दिस इनडायरेक्ट एड्रेसिंग मोड? इनडायरेक्ट एड्रेसिंग मोड हमने इफेक्टिव एड्रेस में स्क्वेयर द ब्रैकेट्स रिप्रेजेंट्स इफेक्टिव एड्रेस, इफेक्टिव एड्रेस में और एक इफेक्टिव एड्रेस रहेगा, वो इफेक्टिव एड्रेस से आपको ऑपरेंड मिलेगा। समझ गए आपको काजल जी? अगर आपने ये इफेक्टिव एड्रेस अगर आपने एक रजिस्टर में स्टोर कर रहे, अगर आपने इफेक्टिव एड्रेस एक रजिस्टर में स्टोर कर रहे, उसको हम बोलते हैं रजिस्टर इनडायरेक्ट एड्रेसिंग मोड। दैट आल्सो विल डिस्कस। ओके, चलो लेट अस गो फॉर द नेक्स्ट टॉप, register addressing mode. First we'll discuss the register addressing mode. Simply there are registers. The address field of instruction specify a register or a pair of register which holds the operand. Simply we can take the registers move a comma b, both the operands are registers. So the data transfer is between register to register, then usko hum bolte hain register addressing mode. So this is 8085, this is our microprocessor, this is for 8085 move al comma BL, okay, and we can write this as move a comma b. This is 8051. Okay, and here I can write move ax comma bx. So these all are register addressing modes. You understand? These all are register addressing modes. Very good, very good, very good. Source register, destination register. And how many number of memory references here? Can you answer, 𝐂𝐬𝐿? The number of memory references here will be what? The number of memory references. How many number of times the memory is referred here? The number of memory references here. Previously, how many number of memory references here? The number of memory references is 2. The number of memory access to get the operand is 2. And here, the number of memory references is 1. Okay. Here, the number of one time you are accessing now. So, the number of memory references. And how many times the memory is referred? The number of memory references is 1 here. In which addressing mode? In direct addressing mode. And here the number of memory references is how many? Previously the number of memory references is 2. But here how many times the memory is referred? Answer my question. That was an expected question. In register addressing mode, are we referring to any memory location? No. 0. How are you referring to any memory location? No, na. It is a data communication is happening between register to register, na. Nowhere we are related to the memory right here. Nowhere related to memory here. So please make a note of this point, my dear. Mistake mat karna. Is it clear, bhai? Answer clear हो गया काजल जी? Number of memory references 0. Are we concerned with any register? Are we concerned with any memory here? No. We are taking the data from the source register. This is a source register. This is a destination register, right? So between the source register to destination register, there is no source register to destination register. There is no involvement of memory. So very important question, 𝐂𝐬𝐿. These are the expected questions here. Number of memory references in the register addressing mode is 0. Number of memory references in the indirect addressing mode is 2. Number of memory references in the direct addressing mode is 1, my dear. Okay, miss mat karna. Chalo. Now let us go for the another addressing mode, that is the 6th one. Register indirect addressing mode. रजिस्टर इनडायरेक्ट एड्रेसिंग मोड बोले तो क्या है इधर? अगर आपने जो एड्रेस आपने भेजना चाहते हो, वॉट एवर द एड्रेस दैट यू वांट टू गिव, दैट एड्रेस यू विल गिव इनडायरेक्टली. प्रीवियसली आपने इनडायरेक्टली दिया है, बट हियर वी आर यूजिंग ए रजिस्टर टू होल्ड दैट एड्रेस. सो इफ यू सी दिस indirect addressing mode, in the indirect addressing mode we are taking a address, in that address another address, that another address will be having the operand. But here, instead of using the 2 accesses to the memory, we will split that into 1 access to register. That means what? I will take a register. In the register, I will store this effective address first, and I will use that register in the next instruction. That means what? See here. I will like this. I will write like this. See, I am writing here move. Suppose bx, comma 1000. Now tell me, it is what addressing mode? It is what addressing mode? First of all, you tell me this. Ayinkesh, Kajal, it is what addressing mode? Move bx, 1000. It is what addressing mode? Move bx, 1000. कामा के पास नंबर है. It is what addressing mode? जल्दी बताइए काजल. क्लास इंटरेक्टिव होना है. ये क्या एड्रेस है? जल्दी बताओ. Anybody tell me, move bx, 1000 ये एड्रेस को क्या बोलते हैं हम? ये दिस इज व्हाट एड्रेसिंग मोड माय डियर. मूव bx, 1000. जल्दी रिप्लाई दीजिए. कोई भी रिप्लाई दीजिए. No, it's not indirect addressing. It is immediate addressing. Who said it is immediate address? Indirect. It is immediate addressing. It is the immediate addressing. We are loading. It is the immediate addressing. इसके बाद क्या होगा? bx will be loaded with 1000. bx will be loaded with 1000, my dear. bx will be loaded with. Is it clear? bx will be loaded with 1000. Is it clear? It is an immediate addressing mode. It is not indirect. Why indirect? कामा के बाद मैंने नंबर दिया है. It is a number. Now what I am writing? If I am writing like this, move ax comma within the square brackets, or if I am writing move al comma within the square brackets bx. This is what the bx contains the 1000. So that is what bx is a register. I am using a register bx. So the bx contains the effective address. What is effective address? 1000. bx contains effective address 1000. Okay. So you are going to the 1000. This is a 1000 location. In that 1000 you are having the operand. So it is indirect addressing mode only. But indirect addressing mode को split करके आपने एक पहले एक register लेके register में address का number डाल के and second instruction में वो register addressing mode, register indirect addressing mode को use कर रहे. That means what now? The content of the bx is not the data. The content of the bx is the effective address. समझ गए आपको? And we'll go to that bx register. From the bx register we are taking 1000 value and we'll go to the 1000 address. So one time you are going to get register access, one time you are going to get the memory access. So here one register access and one memory access is required here. Do you understand? So now the content of the bx is 1000. So bx is 1000. We'll go to that memory location. See here. First we'll go to the bx. So this is, let us take al. So let us take this the bx register. Let us take this the al register. The bx contains 1000. So now 1000 is the effective address. We'll go to the memory. In the memory, this is a 1000th location. This is a 1000th memory location. In the 1000 memory location, we are having 44. So now from that 44. So from that 44, this 1000th memory location having the content 44, this 44 will come here. Understood, my dear? So one time you are going to access the register access, one time you are going to access the memory access. Is it clear everybody? जितने लोग लाइव में देख रहे 6 members are watching, प्लीज कंफर्म कर दीजिए बेटा. जस्ट उसके बाद हम जाएंगे फिर से कंफर्मेशन. आई विल गो फॉर द नेक्स्ट एड्रेसिंग मोड. द स्लाइड्स आर परफेक्ट. क्लियर है? चलो, let us go for the next addressing mode. The next addressing mode is auto increment and decrement addressing mode. Very interesting है ये. auto increment and decremental mode. It is the other form of register indirect addressing mode. The content of the register is automatically incremented or decremented to access the sequential data. See here. Let us take this a register. Let us take the register is a count register or something like that. I am taking a register. In the register there is a memory location. It will go to that memory location. So this is a 100th memory location. Then automatically what happens now? In this auto indirect addressing mode, this particular address, it will be incremented. So this is going to be 101 like that. See, for example, I am taking move SI source index some register. I will take any register, move R0 hash 100H. Okay, now sorry, this is move immediate. Okay, MOV move R0 hash 100H. So this is microcontroller. Okay, microcontroller. So now what is going to happen? This particular register is going to be automatically incremented. If I'm repeating this operation, that means I am going to that particular location. I am taking this move a comma at the rate R0. So R0 is a register. The register value is 100. In the 100th memory location, we are having an operand. That operand will come, and again it will be, suppose if I am taking this particular addressing mode, if I am mentioning this addressing mode, you have to mention this as an auto increment addressing mode. You have to mention either is an auto increment addressing mode or auto decrement addressing mode. Then automatically what happened? This register value is going to be incremented or decremented after each and every operation. एक बार ऑपरेशन होने के बाद क्या होगा? ये रजिस्टर का कंटेंट बढ़ जाएगा. So that means this register content is going to become now 101. In 101 another operand is there. You will take another one. Okay, so it will be automatically incremented. So I am taking move b comma at the rate R0. So that means what is happening here? That R0 is incremented by 1. Okay, then I am taking this add a comma b I am using. That means what here? R0 is initially 100. So in 100th memory location we are having certain content. That content is coming to the accumulator. Then increment R0. R0 is becoming 101. So at 101 another content is there, that is coming to the b. I am going to add. So like this increment R0 you are giving explicitly here. But अगर आपने इंस्ट्रक्शन में अगर ए एड्रेसिंग मोड में अगर रिप्रेजेंट किया ये ऑटो इंक्रीमेंट और ऑटो डिक्रीमेंट अगर आपने मेंशन किया, then automatically the memory is going to be incremented or decremented. Is it clear, my dear? Where it is best suitable, especially it is suitable in array type of operations. If you take an array, in the array we are having some numbers. I want to access each number one by one. In that situation, we can use this particular auto increment and auto decrement addressing mode. Suppose the array is having 10 elements. Array of 0 is one number, array of 1 is another number, like index. You understand? Is it clear, 𝐂𝐬𝐴? Chalo, let us go for the next. Next one is the indexed addressing mode. Index addressing mode or index register addressing mode. See here, I am taking a memory location. The memory starts from 100 and 1. Let us take the each size of this particular memory is 2 bytes. So 100, 102, 104, 106, 108. So this is 0. That means this is the 0th index. This is the first index, to second index, third, fourth index. So I want to know this array of 5 elements. Total how many elements? 1, 2, 3, 4, 5 elements. Each element is having 2 bytes. Each element is taking the 2 bytes. So I want to know location of A of 3. So what I will do, the base address is 100. So size of each element is how much? 2. So this array of 5. So if I am taking array of 5, so this array of 5, this is the 0 position, next first position, second position, third position, and the fourth position. So totally how many elements? 1, 2, 3, 4, 5. But this particular location, this is the 0th position, this is the first position, this is the second position, this is the third position, this is the fourth position. But this 0 is an index. But what is the size of each element? The size of each element is how much? 2. Am I right or not? So if we want to go to the third element, what is address? That is a 106. So the base address is 100. The base address is 100. You want to go to the third element. I want to get the location of A of 3. That's the third element. So third element you should multiply with 2. What is a 2? 2 is the size of the index. So this is what we call as 2 is the size of the each element. So then automatically location of A of 3 क्या होगा? 106 होगा. Location of A03. A of 3 कहाँ रहेगा? This is A of 0 sir, this is A of 1 sir, this is A of 2 sir, this is A of 3. A of 3 कहाँ रहेगा? A of 3 का लोकेशन है 106 आ चुका है आपको. This is what we call as index addressing mode. Here index कौन है? That's what we have to see. So if we check now, this is the index. The index register will be the product of W into I. The index register will be the product of W into I. So this is what we have taken now, base plus W into 3. So base plus W into I. So this is the I. Compiler generates instruction. So index register will be W into I, where W indicates the size and I indicates the position. You can take the position. Okay. So the index register will hold this value W into I. So well, W represents the size and I represents the position. So this index register will hold this W into I. Is it clear? Chalo. Now, so here this is our index register. The index register will have this value. For example, if I am taking the index as source index, the source index register is taking as suppose some 100. Okay. So now effective address is a source index. It will go there. So base address taken from the address field of the instruction and the index value from the index register. So base address is taken from the address value. Index register will give this. So base address को ये and index register का value address करना है. For example, my memory is starting from, let us take my memory is starting from 10,000. Our memory is starting from 10,000 location. Okay, let us take 10,000. And SI register is 100. So at a distance of 100, that means 0 plus 0, 100. So if we add, so this will become the 10,100. This is going to be the index addressing mode. Okay. So one memory access is required to get the operand. One memory access, one memory index, one index register access. I will tell you in which way, I will tell you like this. Suppose if I am writing the move SI, 1000, it is also one of the indirect addressing mode. So it is the index register. So move AL, SI. So move AL, SI. So move AL, SI. This is 0100. Okay. So this is the 0100. So then what happens? If I want to go for the next, so what I will do, I will get the increment SI. I will make the increment SI. SI will be incremented. This is 101. So this is the 101, but 101 means this add going to be added to the BL register. So move BL, again SI I am taking. So I am writing add AL, BL. So here what is going to happen? The base address is 10,000. Base address is 10,000. Source index is 0100. So अभी क्या होगा? Into the accumulator 10,100. So the contents of the 10,100. The contents of 10,100. 10,100 is a memory location. 10,100 is a memory location. In the 10,100 memory location, I am having 22. So the 22 will go to the AN. Next, SI is incremented. SI is incremented to become 0101. When it becomes a 0101, then it will be 10,101. 10,101. In the 10,101, I am having some 23. So 23 will go to the BL. That means what is happening here? Every time for the base address, this index register value is added. So base address plus index register will give you the destination address, end address. Is it clear, my dear? So this index register can be incremented continuously. These all are the forms of the indirect addressing only. These all are the forms of the indirect addressing only. In the indirect addressing mode, to represent the effective address, अगर आपने इफेक्टिव एड्रेस को डायरेक्टली रिप्रेजेंट कर रहे हैं उसको डायरेक्ट एड्रेसिंग मोड का बोलते हैं। अगर आपने इफेक्टिव एड्रेस को इनडायरेक्टली रिप्रेजेंट करते हैं इन द फॉर्म ऑफ ए रजिस्टर, देन इसको हमने रजिस्टर इनडायरेक्ट एड्रेसिंग मोड बोलते हैं। अगर वो रजिस्टर आपने इंडेक्स रजिस्टर यूज कर रहे हैं लाइक सोर्स इंडेक्स रजिस्टर, डेस्टिनेशन इंडेक्स रजिस्टर, देन उसको हमने इंडेक्स एड्रेसिंग मोड बोलते हैं। इज इट क्लियर माय डियर? दीज आर द डिफरेंट फॉर्म्स ऑफ द थिंग्स। Is it clear my dear? Yeah, please represent. Chalo, let us go for the next. Next one is the PC relative addressing mode. One of the interesting addressing mode है ये PC relative addressing mode. ये PC relative addressing mode में क्या है ना, we are going to use PC value also in an instruction. For example, let us take this is the starting address, 1000 is the address. Okay, 1000 is the address. What is PC? PC always represents the what? Program counter. Program counter represents the address of the next instruction to be, this is what we call as the program counter. Program counter, it represents the address of the next instruction to be executed. Address of next instruction to be executed. It represents the address of the next instruction to be executed. Okay, is it clear? Thank you, Rohit. Yeah, suppose let us take 1000 is address. In the 1000 address, what I am doing now, I am writing like this: move AL comma some number 1 2. Okay, this instruction takes how many bytes? Can anybody tell me? It takes this opcode 1 byte and this operand another byte, 2 bytes. So it will come 1000 1001 1002 comes here, and here I am writing move BL comma 22. You understand? So every moment this PC will represent, this is the PC. Okay na, this is a PC. PC always represents the address of the next instruction to be executed. While you are executing this instruction, can anybody tell me what is the PC value here? Please tell me. All of you please answer my question. While I am executing this particular instruction, what is the value of the PC? अरे यार मुझे रिस्पॉन्स चाहिए बेटा जल्दी। रोहित, काजल, अंकेश, एवरीबडी मस्ट रेस्पॉन्ड। अगर मैंने ये इंस्ट्रक्शन एग्जीक्यूट कर रहा हूं मूव एल कमा 12, ये पहला इंस्ट्रक्शन है ना, ये पहला इंस्ट्रक्शन एग्जीक्यूट करने के समय पीसी का वैल्यू क्या होता है? काजल जी आंसर बताइए जल्दी। गरम वाटर तो వేసుకోవచ్చు కానీ హాట్ వాటర్ तो बताओ बेटा क्या हो गया? पीसी का वैल्यू कितना होगा? अरे यार आंसर बताइए, कितना टाइम ले रहे हैं आप? When I am executing this instruction, what is the value of PC? PC will be representing the address of the next instruction. The address of the next instruction is the 1002, my dear. अरे कुछ तो कुछ रेस्पॉन्स दीजिए भैया। 1002. While you are while the processor is executing, while the processor is executing this instruction, the PC will be always points to the next instruction address. अगर आपने इधर गया, ये इंस्ट्रक्शन एक्सिक्यूट कर रहे, उसी समय पीसी का वैल्यू कितना होगा? एटलीस्ट यू आंसर दिस। पीसी का वैल्यू कितना होगा, जल्दी बताइए। अरे ये तो मिनिमम अंडरस्टैंडिंग है ईसी बच्चों के लिए। प्रोग्राम काउंटर ऑलवेज रिप्रेजेंट्स द एड्रेस ऑफ द नेक्स्ट इंस्ट्रक्शन टू बी एक्सिक्यूटेड माय डियर। Answer please. What is the answer now here? At least the answer here is what? Again, what is the size of this instruction? यार, this will take 1 byte, this will take 1 byte. जो कुछ कामा के बाद है ना, कामा के बाद जो कुछ भी हो, it will take 1 byte. So ये कितना होगा? 1002. This will be 1002. 1003 गया, 1004 आएगा. This will be 1004. 1004. क्या हो गया यार? I'm not getting answer. What is the problem, काजल? So PC always represents the address of the next instruction. Always remember, PC always represents the address of the next instruction to be executed. Is it clear? PC represents the address of the next instruction to be executed. Is it clear? अरे यार मुझे रिस्पॉन्स चाहिए भाई, रिस्पॉन्स नहीं तो मैं क्लास बंद करता हूँ। इतना फ्री में आपको इतना अच्छा कंटेंट दे रहा हूँ, आप कुछ रिस्पॉन्स ही नहीं दे रहे। 5 7 6 लोग लाइव में हैं, मैं क्वेश्चन पूछ रहा हूँ, क्वेश्चन को लाइव क्लास में आंसर कर दो। लाइव क्लास में आप किसको पार्ट पढ़ा रहे हैं? बच्चों को पार्ट पढ़ा रहे हैं, कैमरा को पार्ट पढ़ा रहे हैं, सिस्टम को पार्ट पढ़ा रहे हैं। इतना अच्छा कंटेंट दे रहा हूँ, आपसे कुछ ना कुछ रिस्पॉन्स होना चाहिए काजल जी, रोहित जी। चलो, now what is the PC relative addressing mode? I will give an effective address, but the effective address, how to calculate the effective address? This effective address involves the PC value as well as the address. That means suppose if I am writing move any instruction, move AL comma 200, इसके साथ साथ मैंने ऐसा लिख दिया, if I mention like this, that means what? What is effective address now? The effective address will be the value of this 2000 plus the value of the PC. Suppose if the PC is equal to some 1000, when you are executing this instruction, what is the PC value? See, very interesting question this is. I will tell you one important way like this. See this. I will tell you one important way. So you have to understand the origin of this problem. So this 1000 is address location, my dear. 1000 is address location. So here I am writing move AL comma move AL comma. Here I am writing this is 2000. Okay. Move AL comma 200, and इसके साथ साथ I am writing the PC. First of all, tell me what is the PC value. If you take this is the opcode, it will take 1 byte. This is effective address, it will take some bytes, and it's effective address. So what is the PC value? Anybody can tell me? So this is an opcode, so this is an effective address. Suppose this effective address take 2 bytes, this is 2 bytes. So 1000, 1001, 1002 gone, 1003, 1004 gone, it points to the 1005. So the PC points to 1005. So that means the effective address will be, the effective address here कितना होगा? The effective address here कितना होगा? 1000 plus this 200 plus PC value is 1005. That will go to some different location like 2205. It will go to the memory location 2205. So in the 2205 we will be having, for example, the PC value is 1005, the base address is 1000, so the effective value is going to, in addition to this effective address, we are having the 200, So this is 1200 actually. This is a 1200. 1200 plus. Understood? Very interesting है PC relative addressing. PC relative addressing mode will use the PC address also in addition of the effective address. That is the point. Is it clear? Chalo. Let us go for the next addressing mode. Base register addressing mode. Simple yaar. If you are using the base register address, that's a base addressing mode. That means if I am using move AX comma, in addition to this, if I am using the BX register, then it is called the base addressing mode. Okay. Thank you. Next. So these are the things we have discussed up to now. So implied addressing mode we have discussed, immediate addressing mode we discussed, register addressing mode we discussed, register indirect addressing mode discussed, direct addressing mode we discussed, indirect addressing mode discussed, and auto increment, decrement, index, these are computable. So here effective address has to be calculated, effective address has to be computed. Effective address is computable. You have to compute, you have to calculate the effective address, but in this case effective address calculation is not needed. Effective address is not computable here. For all these cases, effective address is not computable. Please make a note of these points. Or if you go through this, take a short break of 5 minutes. After that, we will start the 5 minutes. Now we'll start the pipelining. What is pipelining? Please make a note of it. Pipelining का मतलब क्या है? तो अब स्टार्ट करेंगे पाइपलाइनिंग. सो पाइपलाइनिंग बोलो तो क्या है? पाइपलाइनिंग का मतलब है prefetching the next instruction while the present instruction is under execution. So this is one example. Prefetching the next instruction while the present instruction is under execution is called pipelining. Suppose if you have a series of inputs need same operation to be performed, then pipelining can be applied without changing much of hardware resources. For example, if I want to perform addition of two numbers 2, 3, or I am having a sets of numbers 1, 2, 3, 4, 5, 6, like I am having operands, some 10 sets of operands are there. Set number 1, 1, 2, set number 2, 3, 4, set number 4, 5, 6, like that. So I want addition of 1 plus 2 separate, 3 plus 4 separate, 5 plus 6 separate. I am having a series of operations to be performed continuously. That means the numbers are changing, but the addition is always same. Okay, 1 plus 2, 3 plus 4, 5 plus 6. The numbers are changing, but the addition is same. Do you understand? Okay, so in certain situation, the sequence of operations are same. Only the numbers are changing. So if I use certain methodology, there is no need to go for much modifications in the hardware resources. So that tomorrow it may be 100 sets or 1000 sets also I can do it. Okay. So when a series of inputs need same operation to be performed, then pipelining can be applied without changing much of the hardware resources. Okay. So what is pipelining? It is a technique to decompose a sequential process into sub operations. For example, if I am taking the adding two numbers, taking one number and storing in one register, taking another number, storing another register. This is a sequence of operations. So I will divide this addition of two numbers into set of operations. Taking an operand 1, taking an operand 2 is the first step. Adding them, operand 1 plus operand 2, second step, and storing the result, that's the third steps. So I am dividing into segments. So first I will divide this into segments and I will repeat the segments for the different sets of the numbers. So technique is to decompose a sequential process into sub-operations. Sub-operations are performed in segments plus task, one operation performed in all segments. Okay, see here. I will tell you one number. Example I am giving. I want to make addition like this. I want to AI into BI plus CI. That means what? This is a product of two numbers and isko C add kar raha hu, where I is equal to 1, 2, 3, 4, 5. Okay. So what are the sub operations here? All of you are there. Please give me some response, my dear. It is one of the important topic. I need a response from here. It is not like that YouTube class है हम नहीं देखते हैं, हम तो response नहीं देना है. रोहित जी, everybody जो लोग live में है कुछ response दीजिए. ये live class में हमने इतना अच्छा concept discuss कर रहे हैं, आपसे कुछ response आना चाहिए. So I want to perform this AI into BI plus CI. That means I want to perform 1 into 2 . For example, if I am having a sets like this, set number 1, I am having three numbers 10, 20, 30. Set number 2, I am having 40, 50, 60, like this. Set number 3, okay, 70, 80, 90. Set number 4, 100, 110, 20. Set number 5, 130, 140. Okay, so these are the 5 sets. I'm taking these 5 sets. I'm taking these 5 sets, 10, 20, 30, 40, 50, 60, 70, 80, 90, 5 sets of the data I'm taking. Okay, so what I want now, I want 100, 10 into 20 plus 30, next 40 into 50 plus 60, next 70 into 80 plus 90, next 100 into 110 plus 120. This is what I want. Okay, so this is I am taking as variable A, this is I am taking as variable B, this I am taking variable C. So what is my sequence of operations? I have a repetition now. What is that repetition? A into B whole plus C. This should be repeated for all the 5 sets. Okay, so in performing one particular task or in execution of one particular set, what are the sub-modules? First, get the content into R1 register and get the another one B into R2 register. This is the first thing. And next, the third, second, this is a segment 1. I am taking this as a segment 1. I am dividing into sub operations. What are the sub operations? Segment 1, what I will do, so first I will take the A1 into R1, next B1 to R2, A1 to R1, B1 to R2. So this is the first segment. A1 to R1, B1 to R2, this is the first segment. Next, segment 2. Segment 2 I am taking like this. I will take this product R3 is equal to R1 into R2 and moving this C into R4. This is a second segment. So this is the first segment, this is the first segment, this is the second segment, and last segment, segment 3 ये है. What is the segment 3? This R3 plus R4 should be added and given. So this R3 plus R4 should be added and the result has to be stored in the R5. So this is the way how all the sets have to be continued. This is for the first set. Now here I will do one thing. I will do some parallel operation. What is that parallel operation? While I am doing this segment 2, the segment 1 can run for the set 2. Similarly, while I am doing segment 3, the segment 2 can run for the segment 1. Yes or not? You understand? So how to understand this? I will have created a table. So with the table we'll go. See here, example. I am taking this R1 AI first set. I am taking this first variable AI into R1 and BI into R2. So this is segment 1. Segment 1. Next, I am multiplying using a multiplier and the result I am going to get into this is R3 actually. This is R3 and the C variable I am getting into R4. Okay, sorry, there is a mistake. R3 and R4. So this is segment. तो जो कुछ मैंने मेंशन किया है, so this one, this is segment 2. This is segment 2. Next, I am getting an addition and storing the result in R5. So this is segment 3. And this should be repeated for all. That means if I am doing the segment 2 operation for the first set, segment 1 should be continued for the second set. If I am doing the segment 3 operation for the first set, second set should be continued for the segment 2 and the third set will be coming for the segment 1. You understand or not? जितने लोग लाइव में देख रहे हैं मुझे एक बार कंफर्मेशन कर दीजिए बेटा. इसको कैसे अंडरस्टैंड करना है? मैं एक को अच्छा टेबल से बनाता हूँ. आई थिंक दिस टेबल इज विजिबल टू यू. Yeah, I think it is visible to you now. See here. First clock pulse, I am taking segment 1 R1 comma R2. I am taking the A1 comma B1. Okay. So first segment. So in the first clock cycle, segment 2 and segment 3 we have not yet started. Segment 1 is related to R1 and R2, segment 2 is related to R3, R4, segment 3 is related to R5. So segment 1 में हमने जो कुछ वेरिएबल्स है A1, B1 को R1, R2 को स्टोर कर रहे हैं. नेक्स्ट सेगमेंट 2 में क्या करते हैं ना, ये A1, B1 को मल्टीप्लाई करते हैं और C1 को लेते हैं. सो दिस इज segment 2. एंड व्हाइल यू आर डूइंग दिस segment 2, अनदर segment 1 बाकी है ना, segment 1 एम्प्टी है. सो वो रजिस्टर्स को हम अगेन सेट 2 को इन्वाइट कर सकते हैं. सो सेट 2 कम्स हियर, A2, B2 कम्स हियर. नेक्स्ट segment 3 कब जाता है, थर्ड क्लॉक साइकिल. सो बाय द एंड ऑफ द थर्ड क्लॉकवाइज साइकिल, सो बाय द एंड ऑफ थर्ड साइकिल, by the end of third cycle or not, by the end of the third cycle set 1 is completed, yes or not. But remember, during this third, first clock pulse A1 B1 you are getting, second clock pulse A1 B1 multiplied and C1 getting, that operation is happening, and during that second what is happening here, A2 B2 is also coming. Okay, and during the third clock pulse A1 B1 multiplied with C1 is happening. During that A2 B2 entered here. Okay, so जो कुछ A2 B2 आ गया, so that is going to be added here, C2, and during that A3 B3 is coming here. Today by the third clock cycle first set is over, and the next fourth clock cycle में क्या होगा, this A2 into B2 will be added with C2. So this is the fourth clock pulse. So this is a fourth cycle. So by the end of the fourth cycle this will go out. By the end of the fourth cycle set 2 will go out, set 2 will be out. Next clock cycle this A3 into B3 plus C3 will come. So by the end of the fifth cycle set 3 will be out. Next similarly A4 B4 A5. So at the end of the sixth clock cycle set 4 will be out. At the end of the seventh cycle set 5 will be out. So by maximum 7 cycles it will be out. Suppose if the same operation if you want to do without pipelining concept, what is pipelining? Prefetching the next instruction while the present instruction is under execution, prefetching the next instruction while the present instruction is under execution, or repetition of sequential operations in a systematic way. That is what we call as pipelining. Is it clear my dear? अगर ये पाइपलाइनिंग नहीं है तो क्या होगा, सेट 1 के लिए 3 साइकिल्स चाहिए, साइकिल नंबर 1 A1 B1, साइकिल नंबर 2 A1 into B1 and C1, साइकिल नंबर 3 A1 B1 रिजल्ट प्लस C1. ओके, समझ गए आपको. सो एक पैरामीटर, एक सेट को बाहर भेजने के लिए, बाहर सेंड करने के लिए कितना होना चाहिए, 3 साइकिल चाहिए. आपके पास 5 सेट्स है. दैट मीन्स until first set is completed, suppose if the pipelining operation is not there, until the first set goes out the second set not starts. So how many clock cycles you have to wait? Second set 3 clock cycles. So second set enters after the 3 clock cycles and it completes 3 cycles, and until that the third set cannot enter. అంటే एक सेट को 3 साइकिल्स चाहिए. पूरा मेरे पास 5 सेट्स है, 15 साइकिल्स चाहिए, 15 टी स्टेट्स चाहिए. सो विथ पाइपलाइनिंग, विदाउट पाइपलाइनिंग क्या हो रहा है, विदाउट पाइपलाइनिंग मुझे 15 साइकिल्स चाहिए, 15 साइकिल्स चाहिए. वाई? बिकॉज ईच सेट रिक्वायर्स 3. So 5 sets into 3. ओके, सब विथ पाइपलाइनिंग मुझे क्या हो रहा है, विथ पाइपलाइनिंग मुझे केवल 7 साइकिल्स में वो बाहर आ रहा है, 7 साइकिल्स से वो बाहर आ रहा है. दैट इज अ पॉइंट. You understand my dear? Is it clear all of you? So the time is saved or not? Yes. Chalo. Now let us derive an expression here. Okay. Let us derive an expression. With this expression we will close the session. Consider K segment pipeline. That means the number of segments is equal to K. Number of segments, number of segments is equal to k. Next, with the clock cycle time, so time of clock cycle is tp. To perform n tasks, how many time required to perform first task is k into tp. Okay. Next, time required to perform the remaining task is n minus 1 into tp. See here, मेरा पास कितना सेट्स है? 5 सेट्स है. सो फर्स्ट सेट को कंप्लीट करने के लिए मुझे कितना हो गया? हाउ मेनी सेगमेंट्स? 3 सेगमेंट्स यू डिवाइडेड. सो फर्स्ट सेगमेंट के लिए 3t स्टेट्स हो गया. नेक्स्ट, इसके बाद रिमेनिंग हाउ मेनी साइकिल्स आर देयर? हमारे पास कितना सेट्स है? 5 सेट्स है. 5 सेट्स बोलो तो 5 minus 1 into t. सो कितना हो गया टोटल? 3t plus 4t 7t हो गया ना. That means how we can define, how we can derive an expression for time of pipelining. How many number of segments you are dividing? That into time of pipelining for each task plus number of instructions minus 1, number of sets or number of tasks or number of instructions minus 1 into type of pipeline. That is what the derivation here. That's for the derivation. So total execution time in pipelining. टोटल एक्सिक्यूशन टाइम विथ पाइपलाइनिंग. सो हम क्या ले सकते हैं? k प्लस n माइनस 1 इंटू टाइम ऑफ पाइपलाइनिंग फॉर ईच टास्क. प्लीज मेक ए नोट ऑफ दिस फॉर्मूला. प्लीज मेक ए नोट ऑफ दिस फॉर्मूला. जितने लोग लाइव में देख रहे हैं मुझे एक बार कंफर्मेशन कर दीजिए बेटा. Make a note of this point. Chalo. Now let us go for the next. If a non-pipeline system takes Tn time, so Tn is a non-pipelining time, so then what is the time for n task? N into Tn. Okay. So total execution time for non-pipelining. Total execution time for the non-pipelining. Total execution. This is the first formula. All of you clear, my dear? Is it clear? Chalo. Now let us move for the performance metrics. The performance metrics is non-pipelining time by pipelining time. So non-pipelining time कितना हो गया? Total execution time for the non-pipelining divided by total execution time for the pipelining. So this will be n into Tn and this will be k plus n minus 1 into टाइम ऑफ पाइपलाइनिंग. तो इसको हम बोलते हैं स्पीड अप रेशियो बोलते हैं. क्या बोलते हैं उसको? स्पीड अप. दिस इज व्हाट वी कॉल एज स्पीड अप रेशियो. आइडियल में क्या है? टाइम ऑफ नॉन पाइपलाइनिंग प्लस. दैट मीन्स आइडियल में ये बोथ एंड ये Tn by Tp. सिंपली स्पीकिंग टाइम ऑफ नॉन पाइपलाइनिंग एंड टाइम ऑफ पाइपलाइनिंग. ओके. चलो. If time to perform one task is same in pipeline and non-pipeline, then Tn is equal to KTP. So K ideal. So why? Because what you are taking the speed up ideal, this one na, Tn by Tp. Actually it should be KTP here. KTP. Okay. Ideal case में KTP होगा. So if time of non-pipelining and time of pipelining same, then ideal Why? Because S is equal to Tn by K into Tp होगा ideal case में, so both are equal. Time of non-pipelining is also K into Tp. No, एक सेकंड, यार एक मिस्टेक हो गया, सॉरी एक मिस्टेक हो गया हमने. जनरली क्या है ना, आइडियल सिनारियो में टाइम ऑफ नॉन पाइपलाइनिंग हम दोनों में एक सेम थे, लेकिन टाइम ऑफ नॉन पाइपलाइनिंग इज डिफरेंट, टाइम ऑफ पाइपलाइनिंग इज डिफरेंट. ओके राइट, ओके चलो. तो प्लीज मेक ए नोट ऑफ दिस formulas. Please make a note of these formulas. If n is given, this is a scenario. If n is not given, n is the number of tasks. N is the number of tasks, instructions, okay, n into Tn by K plus n minus. Let us go for a question. GATE CSC में क्वेश्चन आ चुका है. Try to answer this question. Answer this question. What is the answer? Answer बताइए बेटा. Non-pipeline system takes 50 nanoseconds to process a task. So time of non-pipelining is 50 nanoseconds. The same task can be processed in a 6 segments. Number of segments is 6 with a clock cycle of 10 nanoseconds. 10 nanoseconds. Determine the speed up ratio of the pipeline for 100 tasks. N is equal to how much? 100 tasks. What is the maximum speed up that can be achieved? What is the total time of execution for pipelining? That is K plus n minus 1 into time of pipelining. K is 6, n is 100 minus 1, and the time of pipelining is given as 10 nanoseconds. Okay, so 99 plus 6, 105, so 1050 nanoseconds. Okay, सो टाइम ऑफ टोटल टाइम एग्जीक्यूशन फॉर नॉन पाइपलाइनिंग कितना होगा? एक टास्क के लिए 50 नैनो सेकंड्स है, सो n इंटू टाइम ऑफ नॉन पाइपलाइनिंग. सो हियर टाइम ऑफ पाइपलाइनिंग का क्लॉक टाइम ऑफ नॉन पाइपलाइनिंग का क्लॉक टाइम सेम नहीं है, रिमेंबर दिस. सो n कितना है? 100 इंटू टाइम ऑफ नॉन पाइपलाइनिंग कितना है? 50. सो 5000 नैनो सेकंड्स. 5000 nanoseconds. So what is the speed up ratio? The speed up ratio we can take it as total time of execution for pipelining by total time of execution for non-pipelining. So total time of execution for pipelining is 1050 seconds divided by 5000. Sorry, one mistake. It will be coming the denominator, right? Total time of execution for non-pipelining divided by total time of execution for pipelining. Is it clear? चलो कितना आ रहा है आंसर बताइए. Total time of execution for non-pipelining is 5000 and this execution for pipelining is 1050. So 500 by 105. I think it will come around 4 point something. Okay, 500 by 105 एक बार कैलकुलेट करके बताइए. 500 by 105. 4.76. That means the pipeline system is 4.76 faster, 4.76 times faster than 4.76 faster than this. Understood? Please make a of chalo. Let us go for the next question. This is not required for you. Answer this question. Consider an instruction pipeline with 5 stages. How many stages? 5 stages without any branch prediction. Fetch instruction 1 stage, next decode instruction another stage, fetch operand another stage, execute instruction another, and write operand is also another stage. The stage delay of F5, DI, FO, EI are 5 nanoseconds, 7 nanoseconds, 10 nanoseconds, 8 nanoseconds, 6 nanoseconds respectively. There are intermediate storage buffer after each stage and the delay of each buffer is 1 nanosecond. Okay. A program consisting of 12 instructions, the number of instructions is 12, I1 plus I2 plus I3 to 12. In this pipeline processor, instruction I4 is the only branch instruction and its branch target is I9. If the branch is taken during the execution of this program, the time needed to complete the program is dash. So how to do this? See here, my dear, what are the instruction? 5 stages. How to understand this question? See how to understand this question. Consider the instruction pipelining with 5 stages without any branch. So total 5 stages. Number of segments is 5. Number of segments are stages, that is k, that is equal to 5. Okay, what are they? Fetch instruction segment 1, segment 2 क्या है? Segment 2 decode instruction. Next segment 3 क्या है? Segment 3 fetch operand. Next segment 4 क्या है? Segment 4 execute instruction EI. Next segment 5 क्या है? Write operand. WO. Okay, so how much time it takes, that also he has given. What is the time? The stage delays are 5 nanoseconds, 7 nanoseconds, So this is 5 nanoseconds, 7 nanoseconds, next 10 nanoseconds, 8 nanoseconds, next 6 nanoseconds respectively. Okay na? So this is the time for each segment. It's a time for each particular segment. Is it clear? Time for each particular segment. 5 nanoseconds segment 1, 7 nanoseconds segment 2, 10 nanoseconds, like that. And remember, here one clearly has mentioned there are intermediate storage buffer after each stage, and the delay of each buffer is 1 nanosecond. So after this there is a delay of 1 nanoseconds, and this is 9 nanoseconds, and this is 7 nanoseconds. Next, what is information given? A program consisting of 12 instructions, I1, I2, I3 to I12. So number of instructions are 12. Number of instructions are 12. 12. What are they? I1 to I2. But what is happening here? Instruction I4 is the only branch instruction, and its branch target is I9. If the branch is taken during the execution of this program, so here very interesting, I1, I2, I3, I4, I will tell you in this way. Try to understand. थोड़ा सा patience होना चाहिए बेटा. See what are the instruction sequence here. This is the I1, I2, I3, I4, I5, 6, 7, 8, 9, 10, 11, 12. Am I right or not? So total कितना है? 12 instructions. But I4 is a branch instruction. I4 is only the branch instruction, and its branch target is I9. So I4 is a branch instruction, and is mentioned the branch, and this is the I9 is a target. So branch target. So what happens? This will be executed, this will be executed, this will be executed, this will be executed, and after that where the branch jumps to this, and this will be executed, this will be executed, this will be executed. These three are not executed. I5, I6, I7, I8 are not executed. So the total number of instructions executed are this 4, 5, 6, 7, 8. So the actually executed instructions are, what are the executed instructions, my dear? What are they? I1 executed, I2 executed, I3 executed. Once again I'm repeating, my dear. Once again I'm repeating. Total 12 instructions are there. I1, I2, I3, I4. I4 is a branch target. So from this branch we are moving. Once the branch is taken, once the branch is taken, we will move to the target. Once the branch is taken, we will move to the target. So this is a target I9, I10, I10. And कितना हो गया? ये 4. Total 8 instructions only executed. Why? Because you have taken the branch. Once you have taken the branch, I5, I6, I7, I8 cannot be executed. समझ गया आपको? So this is a way. So 1, 2, 3, 4, 5, 6, 7, 8. So total are 8 instructions. Okay. Now what is the question? So if you take the formula, what is the question asked? The time needed to complete this program is asking. So is asking what the time needed to So what is the question? Instruction I4 is the If the branch is taken to the execution of this one, the time in nanoseconds to complete this process. So time of pipelining is asking. So total execution for pipelining will be hoga k plus n minus 1 into time of pipelining. So k is how many segments? Totally 385 nanoseconds होगा. 385. That's it. Yes, that's it. 385 nanoseconds is the answer. Okay, that's it, my dear. So these are the So that's it, my dear. This is a complete topic today, instruction pipelining. I have revised this. Then this addressing modes also I have discussed. Topics to be covered here. I will write one more topic, and is the instruction pipe. Thank you.